Hello, welcome to the third in our series of videos where we solve the questions in the WASSCE 2020 of Dec Elective Math Paper 1. In this video, we're going to solve questions 21 to 30, and we begin with 21. It says, if PQRS are the vertices of a parallelogram, find the coordinates of S. So we can sketch a parallelogram. Now, what we need to remember is that in a parallelogram, you have the corresponding sides being, or if you like, the opposite sides being parallel. So this is parallel to that, and therefore the vectors that represent those sides should be equal. Now, if we write in the coordinates, P is 2, 2, Q is 6, 3. Remember that the coordinates by convention are listed in a cyclical order. So you can go clockwise or counterclockwise. So PQR, R is 4, 5, and then S, we don't know S, so let's represent it by just XY. Now, the vector representing this side can be gotten by taking the difference in coordinates of the endpoints. So this vector represented by the green arrow is P minus S, and P minus S is just 2 minus X, 2 minus Y. Now this vector is equal to that vector, the vector represented by RQ, which is also 6 minus 4, and then 3 minus 5. Now, simplifying this, we have 2 minus 2. So what we have is that this vector is equal to this vector. So we have to equate the components to find x and y. If 2 minus x is equal to 2, then what is x? X must be 0. And then if 2 minus y equals minus 2, then y must be 4. So D is what gives us the right coordinates. The next problem is question 22. It says a non-uniform rod XY 2 meters long. A non-uniform rod XY is 2 meters long and is supported horizontally. Okay, we have a typo. Supported horizontally by 2 pivots placed at X and Y respectively. The reactions are 60 Newton and 40 Newton respectively. So we are supposed to find the weight of the rod. So you have some rod, you can draw it like that, X, Y. So the endpoints are X and Y. It's 2 meters long. It's supported horizontally by 2 pivots placed at X and Y. So there's one pivot at X, precisely at the end point, and then another one at Y, also precisely at the end point. And we are told that the reactions act upwards since the weight of the rod is acting downwards. The reactions are 60 Newton and 40 respectively. And we are supposed to find the weight of the rod. Now the weight of the rod is going to act from some point, the center of gravity. We don't know where exactly it lies on this line, but it's somewhere on this line. And the weight of the rod is going to act downwards. The way we find it is we have to balance the forces. The forces that are acting vertically upwards must be balanced by the forces that are acting vertically downwards. And in this case, the forces acting vertically upwards are the 60 Newton force and the 40 Newton force. That means that this force that is acting downwards must be 60 plus 40, which is 100 newtons. The next problem has the same preamble. We have a uniform rod, XY. It is supported on 2 pivots, X and Y, or at X and Y, and the reactions at those pivots are 60 and 40 newtons respectively. So this is 60 and this is 40. Now we are supposed to find the center of gravity. The center of gravity is where the weight of the rod is going to act from. And in the previous question, we found the weight to be 100. It's just the sum of this 60 and this 40, because that's the only force that is acting downwards, and it must be balanced by the force acting upwards. So this is what we have. We are supposed to find the position of this center of gravity. So this dot, we are supposed to find where it lies from y. So this distance from here to here, let's call it y. We are supposed to find that distance. Now we know that the length of the entire rod is 2 meters. So if the distance from here to here is y, then the distance from here to here is going to be 2 minus y. So let me draw one line like that. We have this distance, which is y. The length of the entire rod is 2 meters, so the remainder of it must be 2 minus y. So here we can find moments about a point. We can first find the moments about x and see if that gives us the result. If it doesn't, we can look at moments about y as well. But in this case, we only need to do for x. So looking at x, we can look at the clockwise moments about x. This is one of them, 100 Newton. So 100 times 2 minus y, that's going clockwise. And then the only other force we have is this upward force, or this reaction force, 40 newtons. That is 2 meters from x. So it must be equal, because that's the counterclockwise moment about x. So we have 40 times 2. So if we solve this equation for y, we'll get our answer. We have 100 times 2, which is 200, minus 100y equals 80. So 100y equals 120, and y equals 1.2. So our answer is C. The next problem, question 24, the statement 5 plus PQ equals 5 plus QP illustrates that. What does it illustrate? Well, we have the 5's here equal, but here we have PQ being equal to QP. This means that the order in which we are multiplying P and Q does not matter. P times Q equals Q times P. That's precisely the commutative law of multiplication. So that's D. The reason we can do this is because of the fact that multiplication is commutative. The next is 25. Find the locus of points 10 centimeters from P, which has coordinates 0, 7. Well, the locus of points 10 centimeters from P, 0, 7, if we represent those points as x, y, then what do we have? We have that the distance between any such point and P, and what's the distance? X minus 0 squared plus y minus 7 squared, the square root of that. Okay, the square root of that is equal to 10. So this is the fact we need to work with. What did we do? We found a point, a generic point xy that lies on this locus, and the condition it must satisfy is that the distance between this xy and this point 0, 7, and that's x minus 0 all squared plus y minus 7 all squared, the square root of that distance must always be equal to 10. So we now simplify further to see what we get as an equation. We square both sides first of all. when we do, we just get rid of the square root. So we get x minus 0 squared plus y minus 7 squared equals 10 squared. We simplify further. X minus 0 is just x. So we have x squared plus, we expand this. This is going to give us y squared minus 14y plus 49. And this is going to be equal to 100. So we simplify further. If we want to bring everything to the left side, we have x squared plus y squared minus 14y. Then we have 49 minus 100, and that's minus 51, and that's equal to 0. So that's precisely D. Now if you're able to recognize that this is the equation of a circle, that's a very good thing, and it should be quite straightforward from here that this is going to be a circle. But you should also be able to recognize that the locus of points that are always 10 centimeters from another point is going to give you a circle. So this point P 07 is going to be the center, and the locus of the points, or the locus, is going to be all these things, and each of these points is going to be 10 centimeters from the center P. The next question is question 26. Given that P is such that xy goes to minus xy and Q is such that xy goes to minus yx, given that these are two linear transformations in the xy plane, find the matrix representing the composite transformation QP. Now QP, when it's written this way, means that first you have to apply P, and then after that you apply Q. So we can look at our canonical points, the point 1, 0, and we look at what happens when you apply P to 1, 0. When you apply P to 1, 0, what happens to it? Xy, for P, xy goes to minus xy. So here we get minus 1, 0. And then when you apply Q to it, what do you get? Q says xy should go to minus yx. So we have minus y minus 0 is still 0, and then x is minus 1. So the transformation QP, this transformation, when it is applied to the point 1, 0, what it does is that it transforms 1, 0 to 0 minus 1. Now let's look at what happens when we apply the transformation to 0, 1, which is our second canonical point. We have, when you apply P to this, what does it give you? It gives you minus xy. Minus x is minus 0, which is still 0. Y still 1, so it leaves the point unchanged. Then we apply Q to it. Q says xy should go to minus yx. So what do we have here? We have minus y, which is minus 1, and then x, which is that. So applying QP to 0, 1 takes it to minus 1, 0. So what is going to be our matrix QP? Our matrix QP is going to be, we take this one, 0, minus 1, and then we take this one, minus 1, 0. That's what our matrix does to the canonical vectors. So that's the answer, and that looks like B. All right, the next one, well, looking at it, I see that A and B have the same answer, so that's probably a typo, but the correct answer is this one. So whether it was A or B, I think when it was being typed there was a mistake and they ended up being the same, but that's the answer. Let's look at 27. It says the table shows the points earned by 5 contestants in a competition. So 5 contestants, these are their scores, event 1, event 2. We are supposed to rank the contestants in each event and find the absolute difference in the ranks for Q. So when we rank them, let's look at event 1. So we can have this P, Q, R, S, T. For event 1, we have to get their ranks. Who was first in event 1? R was first. Who was second? Here we are just going by the magnitude of the scores. T was second. Who was third? P was third. Who was fourth? Q was fourth. And who was fifth? S was fifth. In the second event, event 2, who was first? T was first. Who was second? R was second. Who was third? Let's look at S was third. Who was fourth? Q was fourth. And who was fifth? P was fifth. All right, so this is it. We have to rank them. And if our ranking is right, then the next step is to find the difference in ranks for Q. We see that Q was fourth in both events. In the first event, he was fourth. In the second event, he was fourth. So the difference, the absolute difference in the ranks for Q is 0. He was fourth in both events. All right, the next question is 28. Which of the following lines are parallel? These are lines, so all we need is the gradient to know which lines are parallel. What's the gradient here? When you write the equation of a line in the form y equals mx plus c, then the gradient is m. So we just have to write this in that form. When you do, what do you get? You get y equals minus 3 x minus 1 all over 5. So the gradient here is minus 3 over 5. What about here? If you write it, what do you get? You get minus 5x minus 1 all over 3. So the gradient here is minus 5 over 3. And then the last one, when you write it, what do you get? You get minus 6x plus 7 all over 10. So the gradient is minus 6 over 10. Now minus 6 over 10 is the same as minus 3 over 5. So we have this one and this one having the same gradient. That's I and I. The next one is question 29. It says find the range of the function that 2x minus 5 all over 3. Now this function is defined for every value of x, and it is beyond that, it's also a straight line. It means that every value y can be attained. When you draw your axis, you're going to find that every value of y can be attained. And so the range is the whole of the set of real numbers. Now what these other options are seeking to do is they are seeking to eliminate some value of y. They're trying to say that there is some value of y that cannot be attained. And there's no reason to think that. Normally, when the denominator is some quantity or some expression like x minus 3, then you say that because you don't want this to be 0, you're going to say that x cannot be equal to, let's say, 3. But that's not what's going on here. We just have a simple straight line. Every value of x is attainable. Every value of y is attainable. Okay, the next is question 30. We are supposed to find an integral. We integrate this from 1 to k, and k is greater than 0. We're supposed to find the value of k. So let's integrate 2x plus 2. What do we get? Increase the power of x by 1. You get x squared as the integral for 2x. The integral for 2 is just 2x. And so we evaluate this at 1 and k. And what do we get? We first put k in it. We get k squared plus 2k. And then we put 1 in it. What do we get? We get 1 squared plus 2. So we have k squared plus 2k minus 3. Now we've been told that this thing is equal to 12. So this quantity must be set equal to 12. So let's do that. We have k squared plus 2k minus 3 equals 12. What do we do next? We can bring the 12 over. Then we get minus 15 equals 0. And now we can factorize. What do? We can get plus 5 minus 3 is equal to 0. That gives us k equals minus 5 or 3. Now we're told that k is greater than 0. That means that 3 is the answer we're looking for. Alright, this brings us to the end of our video. We've solved questions 21 to 30. The remaining questions, that is questions 31 to 40, are going to be solved in the next video. See you then. Bye.